Okay, we're starting standard 5, and first, there's quite a bit on this standard. Okay, it's not real short. You should have these two sheets with you. Let's explain some things about exponents that you've seen from Algebra 1. Okay, 3 to the 4th power, 3 is the base, 4 is the exponent. So when I say base, that's kind of the big number, and then the 4, and then how to simplify that, obviously, is you use 3 as a factor 4 times, because 4 is the exponent, and that's 81. There's also a way to figure those exponents out on your calculator. You go 3, and then to make a power, you hit this upside down V, and 3 to the 4 is 81. Now there's some rules you also have to know. Now let's say I have a base of x. I don't know what number the x is, don't really care, okay? But the x is to the 3rd, and it's being multiplied by another x that's to the 4th. So the bases are the same. So to multiply two bases that are the same, you can really just sit, and here's how it works. X to the 3rd is x, x, x. X to the 4th is x, 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 x. So how many factors of x does that make? 7. So to multiply two of the same base, you just add their exponents together. 3 plus 4 would be 7. Okay, now sometimes it's x to the 3rd power raised to the 2nd power. It's what's called a power to a power. So here's how this works. It's really simple, but I'm going to need to show you why it works the way it does. So x to the 3rd I would write out as a factor twice because of the 2. And then x to the 3rd would be 3 factors of x. X to the 3rd would be 3 more factors of x. So how many x's does that make? Makes 6. So to take a power to a power, you just multiply the powers together, okay? 3 times 6, so it'd be x to the 6th. And then to divide two of the same bases. X to the 7th, x divided by x to the 2nd. So x to the 7th would be 7 factors of x, and x to the 2 would be 2 factors of x. But when we're dividing, we can cancel out common factors. And how many x's am I left with in the numerator on top? We're left with 5, okay? So x to the 5th. And to divide two exponents of the two bases with the same exponent, you to divide two of the same base, you can subtract their exponents, okay? So what we're given in this assignment is a bunch of kind of complex expressions. You don't see any adding or subtracting. We are going to do some adding and subtracting, but you don't see it at the beginning of the problem. Okay, I've got a base of 3, and then x to the 2nd, and y, that's in a parentheses, and then the 2 belongs to everything in that parentheses. Multiplied by x to the 3rd, and multiplied by y to the 4th. So we need to simplify that. They're not equations to solve, you're just simplifying it. Okay, so what I'm going to do is make 2 boxes. What I like to do on this is I like to kind of underline the expression to know where things are at. And I just kind of like to make 2 underlines right here. That's just me. Now my first question is, what are the bases we have? First off, what are the numerical bases we have? We have 3. And these other numbers are not exponents. We just have the 3. Times. And now let's look at our variable bases. Well, I've got x. Now I know there's 2 x's, but we want to just write one of them down. And I also have y. We write one of those down. Okay, so here's what I'm going to do. Let's decide what exponent goes on the 3. Well, the 3 is currently to the 1st power. So if it doesn't have a power, it's to the 1st. But it's in a parentheses, and everything in this parentheses is raised to the 2nd power. So what we do is we take the 1 times the 2, okay? And 1 times 2 is 2, so the 3 ends up to the 2nd power. Okay, now x's, we have 2 of them. Let's look at the first x. Okay. Excuse me. So there's two x's, okay? The first x is to the second power, but again, it's in parentheses, so I need to take 2 times 2, which is 4, okay? And then there's another x that's just to the third power, so I put 4 comma 3, and since they're both on top, I just add them together. 4 plus 3 is 7, so x ends up being to the 7th power. We'll have 7 factors of x. 4 factors from here, and 3 from here. Okay, now y. The y is to the first power. And it's in parentheses, so 1 times 2 is 2. And there's another y factor that would be to the 4th, and we want to add those together, and 2 plus 4 is 6. Okay, now the next box we need to do is we need to simplify the powers that we're able to. Okay, 3 to the second can be simplified. That's 9. Okay, but the variables, since we don't know what letter those are, that's going to be x to the 7th. That's going to be y to the 6th, and that's the answer. Now, if you're wondering, why did you make the line? Why did you draw those lines? You'll see as we move forward. All right, next problem. I underline it because sometimes we have to pay attention to whether a base is under the line or not. Okay, my numerical bases, I have a 4 and I have a 2. So those go first. And then the variable bases, I have A, but we only write that down once, and I have B. Okay, so 4. 4 is to the power of 1, but it's in parentheses, so we need to take 1 times 3, and there is 3 factors of 4. 2 is to the 1 power, but again, that's in a parentheses, and everything in the parentheses is raised to the second, so 1 times 2 is 2. Okay, now A. Now there's 2 factors of A. Okay, so 2 times 3 is 6, so there'd be 6 factors, comma, and then 3 times 2 is 6. So 6 plus 6 is 12. You add those because they're both in the numerator on top. You'd have 12 factors of A altogether. Okay, B. B is to the 1, but it's in parentheses, so we need to take the 1 times 3, and that's 3. And this B is to the first power. If it doesn't have an exponent, it's to the first, and then 1 times 2 is 2. So that's to the 5th. Okay, now I can figure out 4 to the 3rd power. It's 4 times 4 times 4, which is 64. And 2 to the 2nd is 4. And these variables and their exponents will just need to be, we can't simplify those. Now, when you end up with 2 coefficients like this, and they're both on top, they need to be multiplied, okay? 64 times 4. 64 times 4 is 256. So that's a simplified expression. 256 times a to the 12 times b to the 5th. Okay, next one. First off, if you have 2 fractions multiplied together, you can just extend the line so it's all one line, and that's what you should do. This one's a little bit more complicated. Numerical bases, we have 2 and we have 3. And for variable bases, we have x. Just write one of those though. And we have y. Now on the bottom is just more letters that are the same, okay? Okay, so 2 is to the 1, but it's not in parentheses, so it'll just be to the 1, or it'll just be 2. 3 is to the 1, but that's in a parentheses, and that belongs to the 3 belongs to everything, so 3 times 1 is 3. Okay, now here the adventure starts with the variables. There are 4 x's, okay? That's fun. First x is to the 3rd, no parentheses, put a little 3, right, kind of small. The next x is to the 1, and it's in parentheses, so 1 times 3 is 3, another 3, okay? Now this x is to the 1, no parentheses around it, so comma 1. This x is to the second power, no parentheses around it, so comma 2. The parentheses only surrounds the numerator. Does not include that, so the 3 does not get multiplied by 2. Okay, now we are not going to just add those together. Okay, I want you to look at this. I have 3, 3, 1, and 2. Okay. Now I got to decide. The first x comes from the top, and then the next x came from the top, so we'll want to add those, but then the next x comes from the bottom, so I need to start subtracting the bottom x's, okay? Because it'd be like I have 6 factors of x on top and then 3 on bottom. Well, you're going to get some cancellations there like we did on this right here, okay? And that always works. We'll just add the on top, and then when I move to the bottom, I'll start subtracting. So that's 6 minus 1 is 5, minus 2 is 3. So this x, after all that crap, ends up to the third power. Now the y, we have 4 of those as well. So this y is to the third. This y is to the 1, but it's in parentheses, so 1 times 3 is 3. This y is to the second. And this y is to the 1. So I've got 3, 3, 2, and 1. So the first 2 y's are on top, so we want to add those. And then when I move to the bottom, I start minusing. Once you start minusing, don't stop, okay? So we got, again, I think that's going to be 3 as well. Okay, so the hard work's pretty much done. Now, 2 to the first is 2. 3 to the third is 27. X to the third and y to the third would just remain the same. And we are going to need to multiply those two coefficients since they're on the numerator together, and that's 54. Okay, that's the answer. All right, next problem. Okay, number bases. Well, I have a 2, okay? And I have 4 and 5, but you can't put 4 and 5 on top. Those belong on the bottom. So 4 times 5. I'll have a lot of people, they'll just write 2, 4, and 5. But you have to put them on the side that they're on. And then for variables, I have m on top, and I have n on top. Now on the bottom, I have m and n again. I don't need to write those, okay? Don't do that. Now, if there was a new letter on bottom, like a Q, I would put a Q. Okay, but since those letters have appeared on, since those variables have already appeared on top in the numerator, I don't write them. I don't repeat it in the denominator. Okay, so 2 is to the 1. It's in parentheses, so I take 1 times 2. That's 2. Okay, m. How many m's do we have? 1, 2, 3. That's it. Okay, so the first m is to the second, so 2 times 2 is 4, comma. This m is to the 1, but it's in parentheses, so I need to multiply by the 2 out there. This m, 2 times 2 is 4. Okay, so I have 4, 2, and 4. The first 2 m's are on top, and then the last one's on bottom, so it's plus and minus, and that equals 2. So that m is to the power of 2. Okay, now the n's. There's 3 of those. The first is to the first, so 1 times 2 is 2. 3 times 2 is 6. And then that's to the 1. But it's in parentheses, and that 2 belongs to everything in there, so 1 times 2 is 2. Okay, so I have 2, 6, and 2. Okay, the first 2 n's appeared on top. And then minus, that's going to be 6. Okay, 4. 4 is to the 1, so 1 times 2 is 2. And 5 is to the 1. 1 times 2 is 2. Okay, so 2 to the 4, 2 to the second we know is 4. And then I can't, m to the second, I need to just leave the same. Then n to the 6, I just leave the same. Okay, 4 to the second is 16. And then 25. Now, these two coefficients that ended up on the bottom need to be multiplied together, 16 by 25, and that is 400. And you can circle that answer, or you can reduce, the 4 and 400 can each be reduced by 4, so you'd have 1 and 100. You can do it like that too. Okay, I'm not going to count off for reducing, so I don't want to. Again, if you have one coefficient on top, one on bottom, it is probably good to reduce them, but I'm not going to count off if you don't, but those do need to be multiplied. Okay, now these go pretty quick. Okay, it's the same concept, just underline. Okay, you don't have any numerical bases, you just have a base of y, and you have a 3 and a 7. They're both on top, so you add them. That's y to the 10th. Okay, again, I like to underline the expressions, and that's going to come in handy on the next packet. Okay, you have no numerical bases, just a letter base y, and it's to the second. 2 times 7 is 14, and you can't simplify that. That's just going to be our answer. Okay, underline. Okay, numerical bases, I have a 5 and an 8. And then for variables, I have just x. And there's nothing on bottom right now. So 5 is to the 1. Okay, so 1 times 4 is 4. 8 is to the 1, but it's not in parentheses, so it just keeps its 1. X, there's 2, so we have a 3. 3 times 4 is 12. And then 4. Okay, now I can see that both my x's are on top together, so I add those and I get 16. Okay, 5 to the 4th. Now again, the calculator can do that. 5 power 4, that's 625. 8 to the 1st would just be 8, and then the x to the 16th would just stay the same. Okay, and I multiply 625 by 8, and that's 5,000. You need to times those two if they are on the same side of the ratio line. So 5,000 times x to the 16th power. Okay, numerical bases, I have a 3 and I have a negative 2. Those other numbers are exponents, okay? We don't write those down first, and then x. Okay, 3 is to the 1, so that needs to be multiplied by 2, and that's to the second. The negative 2 is to the 1. 1 times 2 is 2. One thing, if you have a negative base, you should put that in parentheses, okay? If you have a negative base. So x, you have 3 times 2, which is 6, and 4 times 2 is 8. Okay, 3 to the second power is 9. Negative 2 to the second is 4, okay? Remember to put that, if you're going to use your calculator, put that in parentheses. Times x. Oh shoot, I needed to find out. Just a second. Hello? Alright, sorry about that. Okay, 6 and 8 are both on top, so they need to be added, and that's to the 14th power. Okay, so x to the 14th power. Okay, times 9 by 4, and that's 36. So the answer is 36 times x to the 14th power. That's kind of sloppy, sorry. Hopefully you're getting how this works. Okay, moving along. Okay, the line's already there. That's why I draw lines. And the numerical base, there's only one of them, and that's 8. Okay, there are no variables. So I have a 12, that's a 3, a 7, and 2. Now what am I going to do with those? I mean, I got 12, 3, 7, and 2. So the 12 and the 3 are on top, and then when I get to the number, the bases in the numerator, I want to start subtracting the exponents because we're dividing by those. So it's 15, 8, and 6. So 8 to the 6, I'm going to use my calculator to figure out what that equals. 262,144. Okay, underlined. Okay, number bases. I have a 4 and I have a 2, but the 2's on bottom, so you got to put it there. And then I have, for variables, I have an A, And the b, the only b you have is on bottom, so you need to put it on bottom. Okay, 4 is to the 1, so 1 times 3. Remember, the 3 belongs to all this stuff. Okay, so any exponent that comes out of here has to be multiplied by 3. So it's to the third. 3 times 3, and then let's do the a. 3 times 3 is 9. And let's do the 2. It's to the 1, but it's still in the parentheses, so 1 times 3 is 3. And 2 times 3 is 6. Okay, 4 to the third is 64. Times a to the ninth, and then 2 to the third is 8 times b to the 6. You can leave that, or you can leave it like this, that's fine, or you can reduce these. 64 over 8 can be reduced by 8, so that would become a 1. That would become an 8. If you don't do that, that's fine, okay? But that's technically how it's supposed to be simplified. Okay, remember 2 lines, just extend the line. And this is why I make lines on all the problems. So my numerical bases, I have a 3. And then I have an 8, but the 8's on bottom. Then for variables, I have an m on top. And then another m on bottom, but since I've already put that on top, I don't need to put it again. Then I have an n that needs to go on bottom. So 3 is to the 1. And m is to the 4, but it's in parentheses. So 4 times 3 is 12. That third power belongs to everything in that parentheses. 8's to the 1. It's not in parentheses, so it's just a 1. Oh, yeah, there's another m. I'm sorry, I forgot that. So I need to put a comma. And the other m is to the 5th. Okay. Now, this m is on top. This m is on bottom, so we don't want to add. We need to minus those. 12 minus 5 is 7. Okay. And then n, there's only one of them. 2 times 3 is 6. Okay, so 3 to the first is 3 times m to the 7th. And then 8 to the first is 8 times n to the 6th. All right, extend your line. Okay, new number bases, only a couple of them, a 3 on top, and we have a 5 on bottom. And then for letters on top, we have variables, we have x. We also have y on top, and then on bottom I have x, but I've already have that down. And then y, I already have that down. Okay, so 3 is to the 1, so 1 times 3 is 3. The x, there are 3 x's here, okay? Here, here, and here. First x is to the third, but we got to take 3 times 3, and that's 9. The next x is to the fourth, so 4 times 2, that's 8. The other x is to the second, and the parentheses is around that, so you take 2 times 3, and that's 6. Okay, so I got to really think about what I'm doing with 9, 8, and 6. Well, from top, so you add, and then when we go to that x on the bottom, we subtract. That's 11, so that x ends up to the power of 11. Okay, y, there are 3. Okay, so this first y is to the 1, so 1 times 3 is 3. This next y is to the 2, 2 times 2 is 4. This other y is to the 1, so 1 times 2 is 2. Okay, you got to think about what you're going to do because you got 3 of them. Top to top means I add, and then bottom I subtract. So that's 5. Okay, so the y is to the power of 5. Okay, 5 is to the 1, it's in parentheses, so the 1 times 2 is 2. Okay, so 3 to the third power is 27, x to the 11th, and y to the 5th. And in the denominator, 5 to the second is 25. Okay, and 27 over 25 can't be reduced, so. Okay, 2 more. Extend the line. So connect the fractions. You can do that on multiplication. Just make it one fraction. Okay, numerators. I have an 8 and I have a 3. Remember, you got to put the 3 in the denominator. And then on top, we have an x and a y. And then on bottom I have a y. We already have y on top, and an x, I already have that on top. I've already accounted for those variables. So the 8's to the 1, not in a parentheses, so it's to the 1. Okay, x, there's two x's. Actually, hold on here. Let's not do, I don't want to do this problem, okay? Because you're going to end up with a negative exponent. I'm not ready for that yet. Okay, I'm not. See if that happens. That's what the next packet is, negative exponents. Okay, bases, I have a 3 and I have a 2. And you have a 1, but if you have a 1, don't even write that down. And then for variables, you have an x on top, and on bottom you just have another x. So 3 to the 1, so 1 times 2 is 2. The 2 is to the 1, but if you look carefully, that parentheses does enclose the 2. So 1 times 2 is 2. Then the x, I have 3 times 2, that's 6, but there is another x, so I put comma 3. Now this is on top, this is on bottom, so we minus those, because it's like this, okay? You're dividing, so you can just subtract the exponents. So 3 to the second is 9. Times x to the third, and 2 to the second is 4. 9 over 4 can't be reduced, so there you go.